Good morning, everyone. Thanks so much for joining me in my presentation today around the changes that have been occurring with our tank standard. So I'm going to take you through a presentation and show you just what the changes have been. I want to reassure you and let you know that there are actually some companies that are, while they're certified to the current 4766, they're also working with their certifying bodies and have been told that they'll be certified to the upcoming 4766 as well. That's not mandatory, it's a choice that they've made, but it's reassuring to know that certification to this standard is possible, particularly when you've spent the last 2 years of your professional life working on it. So I'm going to give you a very simplified version of what the changes are, and I hope you'll bear with me while I get the presentation ready. Okay, well, let me go ahead and start with this very impressive picture of what rainwater tanks look like in some parts of Australia and New Zealand where we sell the really big tanks. But the standard will be known as 4766 2020. What's happening with it now, I thought probably that's what most of you will have joined this presentation to find out if it's relevant to you. Please stick around if you're a rotomolder or supplier not in the Australasian industry, because there'll still be some interesting information for you on new test regimes that we've added or will add that have potential for the global industry. Well, the final document went through public comment last year, was refined, and all of that comment was reviewed very early this year, and then it was sent to New Zealand because it's an Australian and New Zealand document. So Standards Australia have signed off on the draft. We're now in a position where we're waiting for New Zealand standards to do that. Because of the COVID shutdown there, there's some significant delays. We hope, though, that the standard will be published in July. As soon as I know more about that published date, I'll let all of you know. Perhaps the biggest change in the standard is, very excitingly, that it's much wider than it was before. So it's now not only for above ground rainwater and chemical tanks, it's also for buried and partially buried tanks. And it's much better integrated with several other standards that rely on it. One of the things that we found out in authoring this document was that other standards such as the diesel tank standard, the septic tank standard, and now the developing grease trap standard rely on or refer to 4766 for a design criteria and in some cases an installation criteria, and that didn't exist actually in 4766. So there was a bit of conflict there between those documents. We've been able, in widening the scope of this document, to be able to also align it so that now it's a much easier system for those companies that are producing those kinds of tanks, and the integration of the two documents is much more streamlined. So very exciting to have an underground and partially or buried and partially buried tanks now included in a formal standard in our area. The next biggest change is a move to allowing multi-layer construction. Up until now, there's, remember the first standard was developed or began to be developed in 1998. It was published in 2006, very long process. But the feeling at that time was definitely that we wanted a standard that was just one wall, and that's the way our industry's always produced them. I don't think there's a real intention to move away from that, but we do want the ability to be able to add another layer so that we can still provide a potable internal surface and perhaps a different external surface that will give us better properties. And if you've seen the ARMA update presentation I've done already, that's really around the ability to add perhaps a flame retardant layer that will allow these bushfire or tanks in bushfire zones to better survive the conditions that they have to go through. under the old version of the standard, that would not have been possible because often those materials, flame retardants, are not potable. And so you would have had to make a choice, and we were concerned that that might even further complicate the issue for consumers. So this is another change that I'm very happy and excited has been added. In terms of the definition of a qualified professional engineer, we also listened as a group to some concerns around that, particularly as software now, design software now can print something that looks like a finite element analysis on a tank, but it really isn't. It's something the computer has produced, and it hasn't necessarily been done in conjunction with a structural engineer or someone who would know what they were talking about in terms of whether the design is fit for purpose. So we have tightened this a little. You've probably read it while I've been speaking, but essentially you do have to have a relevant degree. So whoever's driving the software must have a degree that's relevant to what they're doing. And after some concerns that were expressed in public comment, we've clarified it to say that for buried and partially buried tanks, someone with appropriate experience in geotechnic engineering is necessary, but that doesn't mean that they have to do the whole design or the FEA. It just means that if you're working with an engineer that doesn't have that experience and qualification, they may have to outsource that. That's only relevant for partially buried and buried tanks. So getting into the actual document and some of the changes that have occurred, let me take you through those. There's been a clarification of what rework in material is as opposed to recycled. So just to clarify for everyone, rework is the term that we're using when a powder provider puts a batch of material through and it doesn't meet their specifications. It's never been molded, it hasn't even left the factory. We've clarified that that can be reprocessed and then resold as 4766 ready. On the other hand, at this stage, the standard continues to disallow recycled material. We were certainly advised that in other places in the world, recycled can be tested as potable. We were really not sure that our part of the industry was ready for that, or that that material was widely available enough and that that could be well risk managed. So at the moment, rework in the powder supplier is allowed. Recycled material in a tank that's going to store liquid is not allowed. I should say, is not allowed if you comply or certify to 4766. So I will explain more about that at the end of the presentation. Well, probably the most controversial discussion that we had during the development of this standard was around the exposure to light. So essentially the UV stabilization level that we require. In the past, the standard has always been UV8, and we had proposals from staying at UV8 all the way through to a move to UV20. On investigation, the committee decided that an immediate move to UV20 carried some risk to the supply chain or to the availability of that material within the supply chain. And so after long discussion and rigorous debate, it was decided that this version of the standard would remain at UV8. However, we have advised the industry, so the decision was that we would advise the supply chain, and we have since advised them, that in 2 years, the requirement here will move up to UV12. That's because it takes approximately 2 years for the suppliers to be able to do additional testing to certify that their product is UV12 and not UV8. That's not something that can happen immediately for many of the suppliers. So you'll see that there's a commentary which we've added into the standard now to let everybody know that is the intention, and that we will be moving up to 12. Now, 12 was a decision that was essentially made because it's less widely available than UV8, but much more widely available than UV20 around the world. And so I think there is an intention to increasingly require more UV stabilizers, but this is where this standard ended up. There are some other changes that we'll be bringing in 2 years in the next review of this document. In terms of structure and design, that's another area where there's been quite a few changes. David gave a great presentation on the design section of the standard that will be including as part of this conference. So he delivered that last year. It's a recording. But if you want to know the ins and outs of what the design section covers in 4766, that's absolutely a good presentation to run your eye over. It's obviously a very specialist area and a little bit out of my depth there. So, but David gave a really clear idea of the changes. More broadly, we've added in structure and design criteria for above ground tanks, but then also a new whole section for buried and partially buried tanks. And this is where probably the majority of the new part of the document rests, because prior to this, it didn't include buried or partially buried tanks. A lot of work's gone into this section, and that's what David explains in his presentation. There was some changes in the dimensions and tolerances section of the document, and this is really talking about that a type test for material thickness verification will be undertaken. There was some concern in public comment that this is a batch production test. I want to clarify, this is not. So what the standard is talking about here, and we've tried to clarify in the second paragraph, is that when you're making a product for the first time or substantially changing the way you make a product, you will make it according to the FEA and then cut it up and measure it to make sure that your manufacturing processes are achieving what the FEA requires. But you only have to do that once. This is not a batch test. Moving on to batch tests though, and your process evaluation, this has changed quite a bit. And if you are currently certified, it probably hasn't changed at all. If you're working on buried or partially buried tanks, it has some things that you may already do. And this is where we've tried, for example, to make a better alignment between the septic tank standard and the emerging or the currently developing grease trap standard and 4766, because there was parts of this missing. And so clearly, if you're in post-production for your non-buried tanks, you'll do an impact test. And I'm going to talk to you about the changes to the impact test in just a moment. If you're talking about buried or partially buried tanks or septic tanks or grease traps, all of those things that might be working underground, then you'll also have to perform watertight tests and an installation tests. And they're in appendixes, so that's those references. D is the appendix that tells you about how you do a drop impact test. E is how you do your watertight test, and F is how you do your installation. And again, I'll take you through the details of that as we move through the document. Oh, well, and here we are already. So the extensions for partially buried and buried tanks around installation, and this is, I suppose, stepped out in procedure in Appendix F, is really about some special things that you have to do in terms of marking tanks and where they are if they're underground. So there are some new rules within the standard if you're working on buried or partially buried that you'll need to be aware of there. I'm sure that this writing is difficult for you to read, but I'm going to take you through what it says just so that you know, because there have been some changes to marking requirements. Of course, the registered, the manufacturer's name and trademark, if they want to put that on there, the tank capacity based on the conditions of the standard, the specific gravity of the contents of the tank, the date of manufacture and the service life of the tank, and a serial number, and whether it complies with food safe and water safe material standards. What you'll see is missing there is the service temperature. And that's because it hasn't been taken away. You do have to do some analysis that your tank will be able to survive the average service temperature of the area where it's going to be installed. But we've taken that off the marking requirements because it caused real concern with consumers. The reference to 23 degrees made many consumers think that it was only designed to be installed where it was 23 degrees. So while the condition hasn't changed, it's taken off the marking. Of course, you have to put the standard number on there, the roof load limitations, so that we hopefully don't have people standing on them and falling through and hurting themselves. Any earthquake wind loading or snow loading design limitations that that the tank might be subject to. That's only if that's applicable, and your safe fill level for chemical tanks. Then for partially buried and buried tanks, the surcharge load that the tank's been designed for, the backfill properties that have to be used, and the water table level that the tank's designed for. So we also then have just made a note that for manufacturers that are making a statement of conformity with the standard, they have to ensure that the conformance is capable of being verified. In other words, if you're going to say that you conform with this standard, you have to be able to prove that you do. And that's another issue that I'll cover in a moment in the presentation. So water tightness was one of those other areas where I think we found real innovation. There was some concern that particularly for very large underground tanks, an immersion test was just impossible. So we did work in trying to find other tests that would be suitable for rotomolded tanks that will help to ensure that they're fit for purpose and that they're watertight. So you'll see here from this diagram, it's a very rough cut from the rough standard that was submitted in the end. So for your water tightness test, you can use either the water test, the vacuum test, or the pressure test methods in EN 12566, or you can use the immersion method, which is described in Appendix F, Appendix E, beg your pardon, of 4766. So it's laid out in that standard. So you've got a lot more choices now, 3 new ways to prove water tightness in your below or partially buried tanks below ground. So what else has changed? Light penetration tests have been clarified. The design and structure changes I've already mentioned. Some tests are once only, some are batch tests, and we've clarified the table that shows you what batch tests a tank manufacturer will have to go through. And then there's some alternative test methods that I'll take you through. The primary test for quality, post-production test for QR, is drop impact testing. It's a standard that's been around for a very long time, developed by the Association of Rotational Molders in the United States, and it's used widely around the world as the test method to see if we've got where we're supposed to be. It involves dropping a dart from a certain height onto a sample of rotomolded material, usually polyethylene, and it's impacted by the dart, and the impact results tell you or give you an indication of cure and strength. So this proved a challenge for the last standard because the arm drop impact test requires a square test piece, as you'll see here on the screen, 127 millimeters square, And that was a challenge to take out of a tank. It meant that essentially you might have had to have a design where you can take a piece larger than that out of the tank and then put a cap over it, or you had to mold a separate product beside the tank at the same wall thickness on the same cycle to be able to get that piece. We had some submissions from industry to see if we could use the normal cutout for pipe work to do the test, but we had to do some investigation, and David Stootman and his team have been terrific about helping us do some of that work. Tim Lead and his team also did some verification work on this for us. And I'm just going to show you now some samples of drop impact. So this is obviously a pretty good drop impact test result. You can see that the dart's impacted, but the material hasn't shattered and the dart hasn't fallen straight through. These are at different thicknesses or different impact strengths. And what we're doing here is comparing the large square test piece, a large round test piece, and then a smaller round test piece that is the size that's normally cut out for pipe work. And you'll see that the cycle time is written on each of these results. So comparing different cycle times, we got up until now a fairly common result, even with the smaller test pieces. As we start to go into overcure or possibly overcuring the product, we start to get a brittle failure. But the brittle failure occurs more commonly on the smaller pieces. That makes sense because the smaller piece is absorbing much more of the impact than the larger piece. So what this is essentially showing us is that that for cure, and if a part is cured, the results are essentially the same using the much smaller round test piece. If the part is a little bit overcured or a little bit burned or cooked too long, then the smaller round pieces are more likely to fail, which is perhaps even better risk management. So after a comprehensive review of all of that work, the PL046 committee decided that we would make some changes to our version of the drop impact test for this standard that allows the use of a 90mm round test piece. And let me show you what that looks like, again, in the very rough version of the document that's been sent off for approval, because we don't have the approved one back. So you'll see that you can use either a 125 mil diameter square piece, or the 125 diameter round piece, or even an 85 diameter round piece to test. And I think that that will be a great help to manufacturers who want to be able to use a piece that they would normally cut out of the tank to do the drop impact. Well, that's essentially the changes that we've made. I'll tell you about other things that are happening and what's missing. I do just want to quickly cover off something that I visited for the first time last year, which is just the complications of being certified to a standard and how difficult that is. Standards are owned by standards. So this one will be owned by Australian and New Zealand standards. They may send the copyright or award the copyright to another organisation to handle the sales, but it essentially leaves us in the position that not many organisations are prepared to defend on claims of certification or compliance to the standard that are untrue. Certifying bodies, colloquially known as CABs, are normally registered with an organisation here called JASANS, but they don't all have to be registered with JASANS. So if you are interested in certifying to a standard and you're a member of ARMA, please engage with us before you sign up with a CAB to make sure that they're a certifying body that we know will really understand the standard that you're asking them to certify you to, and that they're affiliated with JASANS, which is much better protection for you and for the whole industry. Of course, not all material is suitable for 4766, and that's something else that if you're going to claim compliance rather than certification, then it's on the rotational moulder to make sure that you're seeing the documentation you need to see to make sure that it has what's called a type test certificate. Now, ARMA is certainly aware that some international suppliers have claimed that their material has a type test certificate, but on inquiry have not been able to provide that document. So again, the risk sits on you as the local manufacturer if this material turns out to not be potable. That is not only a breach of the standard, but it's also a breach of Australian and New Zealand consumer laws. So an area for you to be very careful of. First question for a material supplier, can I see a copy of your type test certificate? I want to talk a moment to the industry itself, the tank industry itself, about claims around certification and this standard. So I'm using the existing standard name, which is 4766-2006. It will change to 4020. But the regime that's sitting behind it won't change. You can only make a statement about being certified to a standard, this one or any other standard, if you've used a CAB, a certifying body, to certify that you do meet all of the conditions. If you claim that you're certified and you can't produce a product license, then that would be a matter of real concern and real risk to you. If you say that you comply with a standard rather than that you're certified, you are allowed to do it. It can sometimes cause confusion in the industry. So, and I think anybody would understand that if you were a company that had paid to certify and you had competitors who were claiming they complied and you knew that they didn't, because sometimes it's obvious that they don't, then that would be an issue. So you can only claim that you comply if an auditor could walk in on the day that you claimed it and certify you. So you can't say you comply if you have a type test certificate for your material, but you don't do anything else. You can't say you comply even if you make a beautiful tank if you don't have a finite element analysis on the design of that tank and you can't prove it. So this has been problematic for people who have bought rotomolded tank companies after this standard was published, and they've been sold a business on the basis that their tank standards have been certified or do have FEA, and they've not been able to secure a copy of that. That means that they can't claim that they do comply because they couldn't prove it. You might say that your product is designed to 4766. The problem, of course, is that when you use the term 4766, you can get into trouble in other places as well. But I suppose if you could prove that your design did meet the criteria, then that would be okay. You could say your material is tested to 4766, which would mean that your material supplier has provided a type test certificate. I suppose that the theme of all of these claims is just that they very much muddy the waters in consumers' minds, and perhaps that's the intention, but it shouldn't be. Finally, if you talk about the benefits of certification or standards on your website, so we say, you know, rotomolded tanks have got their own standard, it's a terrific standard, it's an awesome standard, but your standards don't comply or certify, then that really would be misleading and inappropriate for you to do that, to tout the standard as something that's aspirational, that's positive, that's wonderful, but be less opaque about the fact that you don't comply with it in any way. Alternatively, we've seen companies who have certification So they achieve it, they get a product license, they celebrate it, put it on their website, but then the next time an audit is due, they don't have that audit. They continue to market those products as certified. When you do that, again, claims of certification are untrue. If you're a company, and these are real examples that I'm using, if you're a company that was certified and has dropped its certification, then part of dropping the certification must be to amend your marketing to no longer claim that you are certified. Okay, so why would you bother then to become certified? Well, I think if you ask any company that has, you'll find out that they have received a wealth of other benefits apart from the marketing where you can claim that your product is superior because it meets a standard. It helps to manage the risk of industry failure, and in fact, in two major cases of tank failure in other places in the world, moulders have been unsuccessful in action against material suppliers because ultimately, if we want to use an easier example, you're making a cake and you can't really blame the flour supplier if the eventual cake doesn't work the way it's supposed to, because you change it, you do other things to it. That's a real oversimplification, but I hope it helps explain the issue here. So the only way then, because all the responsibility for a tank manufacturer rests on their shoulders to make sure that the tank they're selling is fit for purpose, the standard and the post-production testing regime in this standard is a great way to manage the risk, to make it much less likely that your products will fail in the field and result in much more expensive warranty claims. Additionally to that, the test regime tells you so much about the quality of your processes as well, because you'll start to see production issues before they necessarily are damaging to products that are out there. They're widely recognised by consumers as having real value. And I suppose the last issue here is just to let you know that through our integrity subcommittee, ARMA does monitor claims around standards, and it is one of the things that ARMA responds to probably most often. Complaints from either consumers, regulators, or other moulders about statements and claims relating to standards. Now, we have a documented process for dealing with that, and we have been able to successfully deal with many of those issues that arise. Look, it's not uncommon for a moulder to have a staff member who's gotten enthusiastic about making claims on the website that perhaps the owner doesn't even really know about. That's where we'll negotiate, and if you're willing to work with us, then we will help you clarify those statements and not continue to cause issues that could get you into more trouble. Otherwise, though, I've already mentioned this, if you're a moulder that's certified and you're being disadvantaged by competitors who haven't bothered but claim that they have, I think you would have a right to expect other people in the industry to do the right thing. I've already mentioned our integrity working group. COVID slowed that down a little bit, but we will be picking up and moving on with that work. Now, finally, one of the other frustrations just around this regime is that because the standard isn't really owned by anybody who's got money to defend it, many of the false claims around it have been unactioned. Watermark is a regime here in Australia only that requires certification. So you can't have Watermark if you haven't been independently certified to Watermark. Watermark is owned by something called the Australian Building Codes Board, and they do have the money and the wherewithal to defend claims from companies who claim that they meet Watermark and they don't. So interestingly, in this iteration of what's called the National Construction Code, For the first time, 4766 was referred to in the National Construction Code as required, only on a very few tanks, that's true, so mainly header tanks in tall buildings. So if you supply to that market, you have to have Watermark. We were able to negotiate with the Watermark owners that certification to 4766 would replace their regime for achieving Watermark, and then you only need to pay a small additional amount of money to be able to claim that your tanks are watermarked. I know that some people in the industry have experienced some problems there, the difference between being certified and watermarked, but there are companies who have been able to achieve Watermark on their water tanks already. Again, that's raised some issues with their competitors who have been told it might be more difficult for them. But it is a change, it is possible, and if you're stuck in a vacuum between a certifying body and a Watermark certifying body, again, please get in touch and let us know. Hopefully we can help you find a way out of that and try and fix the system for our members to make it easier to achieve it. Well, finally, the thing that's missing out of this standard that I was very hopeful to have included was this new non-destructive post-production test for cure. And this is exciting whether you make tanks or any other product at all. What we know about cure is that you can define cure, you can see how well a product is cured no matter what the wall thickness, if you can look through it and see where the bubbles are. And cure can be indicated by how many bubbles and where the bubbles are in the part wall. So we've been working very hard with the ROTOMOULDING Academy, which is a joint venture between the French, German, Italian and Australasian associations. We're almost there, but this is another area where COVID has unfortunately delayed us a little bit, as you can imagine. What we've been able to do is all of the science to verify that this test method is possible. So no longer will we need to do drop impact testing to see whether the material has cured. Now, I should say a few things. We want to be able to include this kind of testing in a future version of 4766, hopefully in that one that's coming up in 2 years. But to be able to just replace the drop impact test, we also then would need to have this test, so that is using a special ultrasonic device to take a picture through the wall of the part. That will tell us how well the material is cured, but it won't tell us if the material itself was fit for purpose. So we need to spend the next 18 months making sure that we can answer that question. So in the next iteration, perhaps the 2022 iteration of this document, we'll be able to offer either drop impact and non-destructive testing, or non-destructive testing and some additional method as your key post-production test for cure. Well, that's really all that I've got to talk to you about in relation to the standard. I very much hope that I'll have some good news to be able to share with you very soon, that the standard is out and that through the review we haven't missed anything major. But I suppose I just want to end by reassuring you that the PL 046 committee, the Australian Standards Committee, took all of the issues placed before it very seriously. It was full of industry representatives, so we hope and believe we've got it right. I want to say a special thank you to the huge engagement we had from members. At one point in this process, we were holding meetings every week, every couple of weeks, and we had a huge amount of the industry join into those meetings, provide feedback on the documents and suggestions. And it was only because we had all of that support that we were able to get through this review in the time that we did. It's quite astonishing to be able to do essentially the rewrite of a standard and to have it publishing ready within 2 years. So if you were one of those people, thank you very much for making our life easier. but also thank you for making the industry better. I consider this a legacy piece in my role, and I want you to all be able to do that as well. Well, this is the end of my first online presentation in the post-COVID new norm world. I hope I did all right. Thank you so much for joining. Don't forget to have a look at that presentation from David on the design section if you want to know more there. I hope you enjoy the rest of the conference and that we get to see you face to face again really soon.